So today we're going to talk about how to graph linear equations. Linear equations are an equation whose graph represents a line. And the definition of a line, we need 2 points on the graph in order to create a line. And on a line, we have constant slope and we have points that go along that line. So there are different forms of lines. Today we're going to talk about what standard form and slope intercept form is, and then we're going to jump into what point slope is a little bit later. Okay, so standard form of a line is ax plus by equals c, where a and b are both not 0, and these are all whole numbers, okay? Whole numbers. Or more specifically, we can have integers because they can be positive or negative. Okay, so a, b, and c are whole numbers or integers, no fractions. So a solution, okay, given this problem, thinking about what a solution of the line is. And a solution of the line is just a point on the line, okay? So given this function, or given this line, right, we have 2x minus 3y equals 12. We can find points on this line. We can plug in a value for x and then solve for y and then get a corresponding x comma y point. So let's see how we can find solutions for the line. Here's my x and here's my y. And we often call our x value that we choose our input and the y value that spits out our output. And then we're going to put those 2 points together to get a coordinate point. So let's say I plug in 1 for x. Okay, let's say I plug in 1 for x. That means we have 2x minus 3. Let's bring this down here. That means I have 2 times 1 minus 3y equals 12. So 2 minus 3y equals 12, and we can continue to solve. So y is negative 10 thirds. So that's going to be our output. So we know that there's a point on the graph at 1 comma negative 10 thirds. So what if we plugged in, let's say, 4 for x? Then we have 2 times 4 minus 3y equals 12, and we can solve for y. So that gives us 8, and we get negative 3y equals 4, so y equals negative 4 thirds. Okay, so now we have another point. And if we can plot those 2 points, then we can draw a line. So here we are. So negative 10 thirds as a mixed number is negative 3 and 1/3. And then here this is negative 1 and 1/3. So if I have 1 and then negative 1, 2, 3 and 1/3, I can eyeball that. And then at 4, 1, 2, 3, 4, I have negative 1/3, and we can graph that line. So what we just found by picking points, picking an x value and getting an output y value, we found solutions on that line. So if we think about this line, how many points are there on this line? There are infinitely many points on this line. So doesn't that mean there are infinitely many solutions on this line as well? Because we could pick any point for our x. I could pick 10,000 for x and I can get an output y value. Okay, so there are specific points on a graph that we can find, and they'll be super helpful. So if I have a graph here, we have 2 things that we could find. We can find an intercept, okay? And an intercept is where the graph crosses an axis. So at this point, that would be an x-intercept. And this would be a y-intercept. So an x-intercept is the point where a line crosses the x-axis. And a y-intercept is the point where a line crosses the y-axis. Okay. And so if we're thinking about this point, if I wanted to pick this point, let's say this was 2 over, that coordinate point would be 2, 0. And let's say this was 3 up, that would be 0, 3. So an x-intercept, if it's 2, 0, or any number, 0, that means our y value is 0. And if we have a y-intercept, that means our x value is 0. So we could find an x and y intercept algebraically. So to find them, we want to substitute 0 in for y and then solve for x. And then for your y-intercept, substitute 0 in for x and solve for y. So I would write this down. Okay, so let's practice. To find an x-intercept, I'm going to set y equal to 0 and then solve for x. So I have 3x plus 4 times 0 equals 12. So that gives us 0. So x equals 4. So it's 4, 0 is your x-intercept because we plugged in 0 for y and then got an x value. And then for a y-intercept, we want to plug in 0 for x. So set x equal to 0 and then solve for y. So 3 times 0 plus 4y equals 12. So that cancels out. So we have y equals 3. So that point is 0, 3. I plugged in 0 for my x to get an output for my y. So if these are 2 points on the graph, theoretically, we could plot the x-axis, x-intercept, and the y-intercept, and we can create a line. Okay, so now we also have slope-intercept form. So y equals mx plus b form. And if we solve for y, that means our m is always next to the x, and our b is always added to that x term. Okay, so in order to graph, we need the slope and a point. And this b represents your y-intercept. Okay, so your b value or your y-intercept is at positive 2. Sorry, our slope is at 3. So if we have a point, our y-intercept, that's located at 0, 2, 1, 2. And if we know the slope, can't we plot the slope from there? We can go up 1, 2, 3 over 1, 1, 2, 3 over 1, and graph that line. So we always want to plot that y-intercept first and then plot more points using the slope. Sometimes we're going to have to rearrange a graph and solve for y. So for this one, I can subtract 2x and then divide by -3, but we're going to divide everything by -3. So this becomes y equals 2/3 x minus 3. So this represents our slope, and this -3 represents our y-intercept. Okay, so we can rearrange and solve for y. For number 2, if we solve for y, we can subtract 4x. So notice y equals -4x plus 4. Here is our slope. Here is our y-intercept. So in order to graph the line, we have to plot the y-intercept and then plot points using the slope. So if I start up 1, 2, 3, 4, 5, 6, I can now use the slope. So this is -3/4. I'm going to go down 1, 2, 3, and then over 1, 2, 3, 4. Down 3, 1, 2, 3, 4. And then we can connect the dots.